Thank you very much. So here we are, speaking today about Django generated fields. I'll try to do some example to better understand what they are and how we can use it. They're being introduced in Django 5.0, so they're around for a long time now, but they are still not so largely used, and we are trying to see if we can use more. We can start directly seeing what they look like. This is an example you can find in Django 5.0 release notes. There is a small class, a square, and we calculate the area of the square directly in the database. Unfortunately, it's the only example you can find in the whole documentation. I know that the Django documentation is quite huge. It's impossible to have example for everything. It will be very, very big. So, but I like learning by example and doing things. In fact, what I like a lot is the Django Girls workshop. This is a picture of I took during the Django Girls workshop in Pescara, the first one I organized in 2022. And every time I'm amazed as young girl learn doing things directly and not listening someone explain things, but directly doing things. And has been for a long time also my way to learn things, trying to experiment something and doing directly, and then maybe go back to the theory and deep down. But before going ahead, I want learning from the best speaker than me. I want to say ciao to everyone. And if nobody is someone don't know me, I'm Paolo Melchiorre. I come from Italy, as you can realize. I've been a Python developer for a long time now, and I'm active in the Django community. Right now I'm in the board of the DSF, and I contribute in some different way. I organize PyCon Italia, and I organize some Django World workshop. I contributed as a navigator to the Django node space. But what I like the most is developing with Python and using Django, of course, in particular, working in the database level. And there are a lot of interesting things in the documentation of Django. And one of the things is the section for performance and optimization. We can read very interesting things about the lower level of the computation. Apart from other things, it suggests us to work at the database level to improve our performance. And this is something I like doing because I like database, of course, but also because I found in my career, in my project, every time some solution that improved so much the performance of my project. In fact, my first ever contribution to the Django code has been a specific function for the Django Postgres module. I was working in a project with a lot of instances of model, and I was forced to add a new UAD column. In doing that, working with the Python UAD module, I got frustrated with how slow was. Searching for new way to do it, I found that Postgres already supported it. So after using it for months in my project, I decided to bring back that directly to Django. And it worked quite fast, seconds for updating the value of UID in a columns for millions of records. So in bringing back this functionality directly in Postgres, in Django has been not so straightforward as using my local project, because of course you have to add more tests, documentation, you have to polish a bit your code. And Marcus here and Mark helped me in DjangoCon Europe 2017 during the sprint. This has been a very, very effective way to learn how to contribute back. In fact, I encourage you to participate in the sprint at the end of this conference. what I learned the most was to be aware of all the other database backend that we have in Django, not rely only on your database. And starting from that point, with the confidence of and the help of the other core developer, I started thinking a new feature to add in Django. In particular, I was thinking to bring back in Django something that I learned in another Python web framework, in particular the one I used at the beginning of my career, Zope, which is quite old. I don't know how many of you know about it. Good. And this is a picture of me at the Plum conference in Naples in 2007. And starting from that point, I think I start thinking how of this feature I can be able to bring back in Django. One of these was some computed value. So during the pandemic period in particular, which is in Europe has been very hard, I think also here in the isolation of lockdown, I thought a new feature to add in Django, and I researched a bit. For computed value, I found that there have been already something like that. There was generated columns. They are computed by the database. They are always updated based on other fields. So when you modify a column, these generated columns update based on that, without the needs of any trigger or any Python code at all. So it's been quite promising. But based on the lesson I learned from the sprints, I did some research. So I researched if the support for this generated column was already in all the database backend we support in Django. And luckily, that was the case. So I created a small proof of concept of the code based on the array field I already use in Postgres. And I tried to share this idea with other contributor of Django. And the opportunity was in Python DE in Berlin. I met again, luckily, Marcus and Mark also. And I shared with them some of my ideas, and this one was accepted. And they encouraged me to share with the wider community. Back in the day, we were using the mailing list, the Django developer mailing list. So I sent an email proposing this idea and sharing the reference to the support database, but also proposing to implement it. So we had a long discussion of the mailing list. Someone realized that we had already an issue opened based on the topic, what was a bit stale. So with my contribution, we started again talking about that. And Jeremy showed up and proposed a pull request for implementing it, which was great because at the time I had the time and the capacity to open myself a pull request. I was very happy to see other people creating a pull request based on my suggestion. As you can see from the number of comments, it took a long time to discuss about it. And this was not merged because some esse, particularly if I remember correctly, on Oracle. But luckily, Lily showed up and completed and fixed all these issue. As you can see in this case, we had more comments. And I'm responsible for a lot of them because I wasn't able to contribute with the code, but I tried to contribute in testing manually the code. And I created a list of example edge cases or use case for the utilization of the generated field. And in fact, I collected all these examples I used for testing this pull request. And after the release, I shared a series of articles based on generated columns using SQLite, Postgres, and GeoDjango too. And actually, we are going to see some of these examples, maybe with some addition, and we'll see how to use it more effectively in our code. But before seeing some example, I want to share with you what we have now in Django itself. So the generated field now are a new type of field that is computed by the database without any extra code, and they are totally managed by the database and are always in sync because the database upgrades it for you. You have to specify an expression, which can be deterministic only. We'll see some example of when this does not work. You can't reference another generated field in a generated field, and there are some restrictions based on the database you choose. In fact, we're going to see SQLite and Postgres in this talk. You have to specify an output field, and it more or less is the type of the generated value you are going to create. And lastly, you have to specify if you want to store, if the column will be stored or virtual, but it depends more in the support of your database. For example, in Postgres, you can also only have a stored column and not virtual one. And for example, in Oracle, it's the opposite. You can't have stored column, but only virtual one. But let's go and see using, as in the first example, the SQLite, which is the light database we can use, and which is the default, of course. And let's start also with seeing some beautiful images from Italy. So this is the Pantheon Dome in Rome. I don't know if you ever visited. It's a very beautiful place, and it's still there after 1,000 years. Romans liked a lot circles in their buildings. And in fact, the circles is the class which we are going to create. So it's a basic model. We have only one field, which is the radius, and we want to calculate the area directly using database function. It's not a complex calculation, but it's interesting to see that we already have and Django query set in the ORM all the function and the constants that we need to calculate the area. And I put in all the model example a string representation that can help us to see the starting value and the final calculated value. If we see the SQL code is also immediate, we can see that a similar name for database function are shown here in the migration of our model. And we can see this in action. So we create a circle instance, we define a radius with a number, and we see that it calculates in the representation the area, the number. We can also see what happened under the hoods of in the SQL code, as printing the latest SQL queries our connection performed. In our case, we see that we passed a value for the radius, and what we are in returning is the ID, which is calculated for us, and also the area. And this is the way we have the representation in the top of the slide here. Okay, let's go to see something different from geometric figures. This is another picture from Venice. It's chocolate piece of cake, and we see a price here. And maybe we decided that they're delicious, so we want more than one, for example. So we need a class, an item class with price and a quantity. And the calculation here is way basic than what we done before, but there is a slight difference here. In the quantity field, we defined a database default, which is also a new feature in Django 5.0. And this can help us to have different behavior. For example, we can generate this item and decided to specify only the price, because we saw that the default is to have one piece of this one quantity of this item. And the calculation have an output field which is similar to the price one, and in the presentation we see the formula here. The SQL code of the migration is straightforward. But what we have difference between now and before is the default in the quantity column, which is 1 in this case. And of course, we can see that in action, we can use in both ways, creating an item without specifying any quantity and having the result, or specifying at the beginning the quantity field. And this is what we get. So let's move to another city. This is Bologna. It's the city where we organized the last PyCon Italia conference, and we are going to organize again at the end of May, so everyone are invited to join us. And in particular, this is a traffic light under the 2 towers, which is more or less in the center of the city. Every time I associated the traffic light to finite state machine. So in this case, we are going to create something like that. We have an order class with 2 date time fields. One is mandatory and the other one is nullable. And based on the presence of these 2 date time field, we are going to instantiate the status fields using some conditional expression. I like using this type of condition directly in the database, and here we are going to check if the payment date time field is nullable or is null or not, and based on that we set the status text field to one value or another. The default value is created. Of course, we can add more condition here, but the space of the slide is not so great, and 2 states is enough. And we can represent it having the status and also the one of these 2 date time fields for represent it. What happened in the migration, in the SQL code of the migration, is that we have more or less the same. This condition, and based on the payment presence of the value, we can have the paid on the created status. As before, we can instantiate the order in 2 different ways, specifying only one, the mandatory creation date time fields, and we have, as you can see, the created state, or specifying both the time field. In this case, we know that the order is already paid, and we can print also the date time of this. But we can try to wreck things to see what happens. For example, we decided that we instantiate the order, and when we represent it, we see the created state, and at a certain point in the flow, we want to change, and we want to add the payment date, and we can also save the instance in the database. Unfortunately, as you can see, the status didn't change because at the moment when we save something, there is not returning automatically the generated field. What we have to do is to remember to refresh the instance from the database. In this case, we can use the refresh from DB, or maybe getting again the instance from it. It's something we have to remember when we work with generated fields. So since we want to break things more harder, we can also generate some error here. For example, we decided we don't want to instantiate directly the order, but we only create it, and without saving it in the database, we try to access the representation. Since we customize the representation, and we try to access the status, but it can be read from the database because it's not been saved. The model has not been saved. And in this case, we can do something like that. For example, create a property that has a fallback from the status when it is read and the instance has not already been saved there. Okay, to do more complex thing, we move to another database backend, of course, Postgres. And after instantiating the new database engine, and we are going also to activate the country Postgres module to see something different. We go back to Venice. This is the Acqualta bookstore, which means high water. And if you go inside, you see a pile of books like that. If you are lucky, you have to search to find some very interesting and old books. Otherwise, you buy something very bad stuff. It's like searching the JSON in the JSON field sometimes, which can be contain a lot of data in it. It's complicated to extract interesting things. I created a package model with only a name and a JSON field which contain the data. What we want to do is to specify the name of the package and bring back from PyPy some information on the packages and put it directly in the data and extract automatically the version. We are accessing only 2 levels of keys in this data. We see here the SQL code specific for Postgres and also the syntax that is using Postgres to extract information from the JSONB column. So I tried here to use only Python, the Python standard library, and to try to read the data from the PyPy repository. And after putting directly the data, the JSON data in the data fields, what we have is the representation of the Django and with the latest version. We was able to do that also in the past. For example, without having the generated field, we was able to have a property, for example, to extract directly the version from here. And this is what we get if we do that. In getting all JSON data with a query, we retrieve all the JSON fields that they can be also very heavy to retrieve from the database. So we can do something more slightly different. We can defer the data column, which can be heavy to retrieve, and we can annotate it with the same expression we use in the generated field in this way. Or, as we've shown, we can simply get the new created generated field version deferring the data column. And why it's better to use the generated field? For performance, of course. So I tried locally with ingesting some packages here with 1,000 and 10,000 packages, and it's quite better to use the generated field because you retrieve, you spend only milliseconds on it and not so many time. This is a representation of the numbers. It's a logarithmic scale graphic, but it gave you the idea. So let's go back to Venice. This is a sculpture for Lorenzo Quinn. Give me the idea of connecting things between borders. And what I tried to do was connecting in a person class the two fields. That is very easy, the first and the last name, to create the full name. In this case, we are using the concatenation expression to generate a new char field. The SQL code, we are using the concatenation operation, and what we have at the end is the full name of the person we generated. I'm showing you this. It's not so complex, but in the first release of Django 5.0 for the generated field, this was not possible to achieve because of an issue of a Postgres database. So now we can do that, so let's use it. But we can do also more complex thing in concatenating together text field. For example, we can generate an object, a JSON object directly. In this case, we are using the JSON objects function, and we can apply some transformation to our fields or concatenating the initial of the first name and last name, and then we can represent the JSON we created. In SQL is slightly similar. We define our keys that are slightly different from the value, and we concatenate the two initial. And what we get already calculated for us is the JSON representation we want to get. You can have more than one. You can also decide that this is not the best way to use it, but is give an example of how flexible it can be using GeneratedField. Let's go to Milan. This is the Brera Public Library. It's very beautiful inside, but searching on this amount of text can be intimidating. So for searching in texts, we use the full text search that we already have in the Postgres module, for example. If we have a quotes model with author and text, we can generate automatically a search vector field for us. And we can see this in action. So let's see, we have a quote from Plato in this case. We instantiate the quote. And what we can see with the value list is the vector generated automatically for us. It's interesting to inspect what it contains. And we can see in action that filtering for the plural version of meanings, we bring back the text that contain the singular form of it. So this is a full text search in action. If we want to do this more complicated, for example, let's see, we have quotes in different languages. We can have a new char field languages that contain the language of it. And in the expression, we can use the languages directly to calculate and to have a different type of vectors. This is the migration that Django provides for us, and it fails if we try to migrate it. It failed because, as we said at the beginning, you have to be immutable function. In this case, they are not, because you don't know in advance which language you are going to use in your TS vector. But we can try to do something slightly different. In this case, we still have a char field for our languages, and we decided to use the expression condition that we already used in the past, and decided to copy and paste more time the same expression. But the good point is that we can also have a fallback, a default, using the fallback, the basic dictionary in the full text search in Postgres is the simple one. The SQL code in this case is longer, but it contains everything we need. And we saw also the fallbacks at the end. To see this in action, we have a quote from Cartesius. And as you can see, the search field contains only the vector of the lexem in English. Hi and ham are removed. If we pass the quote with the languages in Italian, we see that it removes also the articles and how full text search works. And if we see the last one example in which we are using Latin, since Latin is not supported by the Postgres database for full text search, it falls back to the simple extraction. And so it extracts the word as they are. So it's an effective way to work around when you have to use not immutable function. And we are going to the Como Lake. It's a beautiful lake, and this is a Grand Hotel Tremezzo. It's very difficult to book a room here. But if we want to book here, we have to specify the range of data when we want to stay. And in this case, we have a booking class with a start and end date time. And we can generate automatically a date range field. To do that, unfortunately, we don't have already the date range function. So in this case, we are going to create a new one on our own using the date range. And the SQL code that generated are very straightforward because instead, Postgres already have the date range in it. And we can see that specifying in the start and end date time, the date here, bring back, and we have a representation of the data range, which is quite useful to specify a data to see if it overlaps with your period of the data you want to put it. Okay, let's go to Trieste. This is a world map in the Miramare Castle, and I show you this image because we are going to use PostGIS backends and GeoDjango. Of course, working with GeoDjango can be simple or complex. It depends from what you want to achieve. With this map from Modena, this is a Cantino world map. Is one of the first map with geographic reference on it, one of the first with the Brazil border. One common thing it's very common to have with map is to have the hash of your point. And in this case, we have a class, a city class with a name of a point. What we can calculate automatically can be the hash of it. And it's very straightforward because in GeoDjango, we already have this function, the geohash function. And under the hood, the SQL code for PostGIS use the geohash function too. In this case, I'm putting in the city in my own town, which this point, and what we get is the hash of it. But we can also do something more complex. For example, we can calculate directly the GeoJSON of our city model. And we already have, luckily in GeoDjango, the function to do it. We can represent directly the GeoJSON fields. And this is what we get when instantiate the same city and we will bring back the GeoJSON. It can be effective if you have to get all these points without calculating again hits. So this is not in Italy at all, it's in Australia, but I wanted to find an example of very long straight route. This is a 90-mile straight route, which is more than, for me, it's strange to think about, but it's quite 150 kilometers long straight route. And so to represent it, I created a route class with a name and a line that represented it. And we can calculate automatically the length of this line in kilometers, of course. And this is the function we have directly in PostGIS. And when we instantiate the route, we see the calculation directly in kilometers for us. This is, I think, the last picture. Who among you know these mountains? Nobody? So it's US, it's Colorado. This is a landscape from Rocky Mountain National Park. Why are we talking about Colorado? Because we are going to represent directly the area of a state. In this case, we have the name of a polygon, and we want to calculate automatically the area of it. And this is what they look in SQL. And why I'm showing you this, because Colorado is more or less a rectangle on the map, which is strange for me. And in searching for border, I found that more or less it's like that. So I finished my time. I show you more motivation to use GeneratedField. Before going away, I want to thank all the organizers, speakers, sponsors, and volunteers here in the conference. You can use this slide and you can download it from my personal website. And the last picture, of course, is from my last trip in Italy. This is the lake of Carezza, which means Cares in English. And it's in the Dolomites, northern Italy. And if you come and join us in the PyCon Italia, you can visit a place like this. So thank you very much.